Hey, geometry, let's start on 2-4. The subject of 2-4 is compositions of reflections. So as I'm writing this down, you all can as well. Compositions of reflections. Okay, I made a mess. Okay, so compositions of reflections. Let's start with a warm-up activity, and it actually has a point. I want to see this in your notes. So go ahead and draw your X and your Y axis. Go ahead and put triangle A, B, C on there, and if it helps, A is at 2, 1, B is at 2, 4, 6, 7, 1, and C is at, looks like 6, 4. Okay, so get that down. Now, pause me as you need to, but the next thing that I would like to see is number 1, reflect triangle ABC over the x-axis. We've got our x-axis. This is awesome review. You know, for point A to reflect it, see how far it is away from that line of symmetry. It's 1 away, so go 1 the opposite way, and that is going to be A prime. Same thing with B. It is 1 away from our x-axis, our line of symmetry, reflected over 1 unit, B prime. Look at point C. It is 1, 2, 3, 4 units away from our line of symmetry, so go 4 the other way. 1, 2, 3, 4, and that is the reflection of C. Put those together, and that is our reflected triangle. Now, we're not done there. Step 2 says to reflect triangle A prime, B prime, C prime over the line y equals -6. So let's go ahead and find that. 1, 2, 3, 4, 5, 6. The line y equals -6 crosses. It's a horizontal line that intercepts the y axis at -6. Okay, so there it is right there. Y equals -6. Now we are going to reflect this one more time. Choose a different color to keep things exciting. Okay, now this time reflecting this one over y equals -6. So let's move C first. That's a great place to start. C prime. I'm sorry, C prime. C prime is 2 units away. Go 2 units over the line of symmetry. And don't worry about naming this one. It's really just to prove a point. Look at A prime. It is 2, 4. It is 5 units away. So go 5 the other way. 2, 4, 5. And then look at B. It is 2, 4. It is 5 away. So from here, 2, 4, 5. Connect those. And I want you to notice something. In doing 2 reflections, a composition of reflections, didn't triangle ABC basically just land on itself again down here? So the 2 created what basically would be a translation, to where if you just slid this triangle down, it would map onto itself perfectly again. Okay, so that's the basis of one of your theorems that you are learning today, is a composition of reflections in 2 parallel lines, and that was the x-axis and y equals -6 in this last example. That composition was basically a translation, which is the transformation where it just slides, okay? So those 2 reflections over parallel lines resulted in a translation. Pause me, get this down. I want to see these things in your notes. Okay, I'm going to keep going though. Now let's move on to this one. Go ahead, draw another XY coordinate plane and get this trapezoid down. Trapezoid PQRS. If it helps, P is at 2, 4, 5. is at 1, 5. Q is at 1, 7. S is at, I don't want to write too much over this. This is at 3, 5. S is at the point 3, 5. And R is at 4, 7. Okay, once you get that down, they want us to reflect trapezoid PQRS in line y equals x, and then we're going to label it. So on that reminder, y equals x, okay, remember that for y equals mx plus b, this still fits that form. Our b, our y-intercept, is actually plus 0. So we are starting here at the origin to figure out what this line is, okay? Then our slope, see how for this slope-intercept form, we don't see an m, it's understood to be 1. So think of that as 1 over 1 for our slope. And that means we go up 1, right 1, up 1, right 1, up 1, right 1, and you just keep on going. See why I didn't want to put that point there a minute ago. Okay, that is going to be, like normally we make a solid line. I'm just trying to show this is what we're going to reflect over. Okay, this is the line of symmetry for this case, y equals x. Okay, let's reflect it. And when it's a line on a slant like this, this is an awesome opportunity to remember how we do that. Let us reflect P first. Let's go vertical and then horizontal. So P, 1, 2, 3, 4, and then go horizontal, 1, 2, 3, 4. That is our P prime. Okay, now let's do S. S is 2 away from our line of symmetry, so we vertically go down, then we horizontally go to the right, and that is our S prime. R, it is 3 units away, so then go 3 horizontally, R prime. And then for Q, it is actually 6 away, 2, 4, 6. So now horizontally go 6, 2, 4, 6. And that is Q prime. Connect those for our cute little trapezoid. Boop, bebop. Okay, and we have reflected it over. Awesome, awesome review. Now keep going. Step number 4 is to reflect this image in the x-axis. Here is our x-axis, and I know they use the language in things that we are reflecting in this line. I tend to say over, but it's the same thing, so don't let the N mess you up. So now we're going to reflect this, imagine mirror image, over the x-axis now, or in the x-axis. I'm going to go back to brown, and this one's easy. We got the hard part over with. P prime is 1 away, so reflect it over. G is 1 away, reflect it over 1 unit. S is 3 away if you count those, so go 3, 1, 2, 3 over the x-axis, and R prime is 4 away, so go 4 the other way. Connect those. Mine's a little rough, but you get the point. Okay, study this, our original pre-image, and study what we wound up with, which I know, a messier one, but work with me here, okay? This is not like where it's just been slid, where it's just, not changed at all. It's not just been slid. What's happened, especially if we take in account this is P, S, R, and Q. Do you see what I'm trying to get you to see here is this? Okay, here we had originally, and we'll get this out of the way, we had trapezoid PQRS. We reflected it again, and notice what happened. It looks like it is getting rotated about the origin, and it maps perfectly onto itself, okay? So this is the basis of our next theorem. a composition of reflections in two intersecting lines. Okay, if you go back and you look, this, bear with me. We've got this line, that was our first reflection, and then we had the reflection over the x-axis. Notice that the pink and the black, those lines are intersecting. And that's what it means there. A composition of reflections in two intersecting lines turned out to be a rotation. Now, honestly, I'm not going to worry too much about this. You've been exposed to it. You've seen it. It may come up on a standardized test. And hopefully it makes sense what those theorems mean now. Now let's move on. The next thing I want you to notice is we're going to look at example 2. Okay, it's in your book, obviously. They're asking you to, in this case, draw lines of symmetry in to get you from here to here by using reflections. Let me focus. Okay, so in this case, and I'm also going to zoom in. Thanks for your patience, crew. Okay, so notice they draw in I'm not sure that helped, but you've got your book anyway. They drew in this line of symmetry, and they reflected P over here. So the blue is the new one. This is the first reflection from P to P prime. And then, if you look over here, they drew another line of symmetry, and they reflected that pre-image now over that line of symmetry. And again, the blue is your new one. It's the final result. So we, again, that helps you see that that is a rotation. Okay, now keep going. Flip the page over, and then we get into compositions of 3 reflections. So we're going from 2 to 3. Bear with me. Bless you all. Again, I know you've got your book, but I'm trying to help you see so I can point. Okay. Notice in this one we're given two figures, and they're going to show us how we can get from here to here with reflections. Okay, lots of reflections, mirror images. So again, remember the blue is the new one. So here's your first line of symmetry drawn in. They reflect J over that, and it lands here. Here's our new J. Okay, we're still not there. We got to get to it with reflections. So then, if you go over here, they draw in this new line of symmetry right there. Okay, and so this is where we were a second ago. And they're going to reflect this J over that line of symmetry, and it lands here. Okay, so at present this is our newest image. So then if you look, they draw in another line of symmetry. It's this one, almost vertical, and then they reflect this J right here. They reflect it over, and it lands here on the blue. This is our new one again. And so they got from here to here using reflections, 1, 2, 3, and then they wind up there. So that was what we were aiming for, here to here. Now you all are probably panicking and going, oh my goodness, how are we going to do this? Well, try not to panic, because I'm not going to make you do that. Even in 2, I'm not going to make you do that. We're skipping that. I wanted you to see it, so breathe now and know that you don't have to worry about this, okay? But I do want you to at least be familiar with Theorem 3.3. In a plane, 2 congruent figures can be mapped onto one another by a composition of at most 3 reflections. And to me, that seems to say we can't go over 3. So at most 3. But what you all are going to have to do is much simpler, and it is basically this. If you look in your book, kind of look down under 3, 3. Notice this J going to this J, took 3 reflections. Here, we can get the same result by going from J to J. We slide, we glide, we translate, and then we reflect over. So we're going to get the same effect by doing something much simpler called a glide reflection. Let's write that down. Zoom out. In a plane, go ahead and write this down. I want to see it in your notes. In a plane, 2 congruent figures can be mapped onto one another by a composition of at most 3 reflections. But, oh, thank you, Ms. Whitaker, we're not going to be doing 3 reflections at once. We can accomplish this same effect with a translation or a glide and a reflection, and it makes perfect sense that we call those a glide reflection. Again, pause me whenever you need to, but I'm trying to hurry up and get through this. So what that's going to look like for your homework is this. For example, find the image of triangle TEX under a glide rotation where the glide is given by the vector 0, -5, and the reflection is in x equals 0. Okay, overlook the mistakes. X is at -2, 1. E is at -1. That's left 1 and up 3. So let me see. X, here's E. Okay, and then T is at -5, 2. So -5, 2, T. Okay, cute little triangle. Isn't it adorable? Okay, so let's do what they're saying here. We're going to start with the glide given by the vector 0, -5. Okay, 0, like with graphing a coordinate point, this first place is going to be going left or right. We're not going left or right any, so then let's focus on the next one, -5. For this one, like your y coordinate, we're going to be going up or down. So since it's -5, we are going to move all of these points simply down 5. So for T, go down 2, 4, 5, T prime, and then for X, go down 5, 2, 4, 5, and then for E, 2, 4, 5, E prime. Okay. Notice that's all we did. Everything just went down 5 according to the vector, okay? And now they want us to reflect that over x equals 0. Well, x equals 0, that would be a vertical line crossing the x-axis at 0, which you're probably saying, hey, that's just my y-axis. Okay, so we are reflecting this, what is now going to be our pre-image, over this, okay? We're reflecting over the y-axis. So you all know how to do this. E prime is 1 away from x equals 0, or the y-axis, reflect it over. X prime is 2 away, so go to the opposite over the axis of symmetry. T is 2, 4, 5 away, so go 5 the opposite direction. And here we go. And I'm going to admit a mistake. According to this book, they're saying that you don't put the primes on here until you wind up with your final result. So if you did that, I'm really sorry. Just mark those out, erase them, and for your brand new image, I'm sorry about that, I knew better. For your brand new image, go ahead and put the prime marks on that. And that shows that that is our final result. That's what we're wanting right there. Aren't those kind of fun? They're not bad. So it's just taking what you already know, it's translating, it's reflecting, and then boom, you got it, okay? So let me see if there's anything else I want to say about that. Yeah. Oh, last thing. Okay, that's enough for now. I may add more in class. By the way, there are only 4 isometries, and if you remember about the isometries, they They are the same size and shape. They were congruent, the pre-image and the image, but we've been over that. So hopefully you know it by now. Those are the reflections. They are isometries. Translations. Your rotations. Let's keep them all plural. I'll be consistent. And these as well, the glide reflections. They are also isometries. Congruent figures. So the reason they've summarized those is you can expect pretty soon we're going to go to some transformations that are not isometries. And hopefully that will arouse your curiosity. So for today, I want you to do practice 3-4 in your workbook, not all of them, so just hang on. When you get to ones like these with kaleidoscopes, you're going to determine the angle between the mirrors. We'll just look and see like what the figure is that's being repeated here. For number 1, this is the figure that's being repeated. And notice it's here, then it's here, and then it's here. Okay, so that is being repeated. There are 3 of those. So divide 360 by 3, and that should give you the right answer. Okay. Okay, I goofed, and I wanted to correct it real quick. I'll go back and edit this later, but for right now, it's actually, look at this. This is actually what's being repeated and reflected, okay? So see, like that is reflected over into that second one. So imagine that mirror image being reflected, and then it's reflected again. Do you see that? It just keeps being reflected. So it's actually 360 divided by 6, and that's going to give you 60 degrees. So my apologies. I knew better than that. So again, that is what is going to be reflected in your kaleidoscope. So for this one, think about it, 360 divided by 8. Okay, sorry about that. I know better. I get in a rush and I mess it up. Don't worry about this. I don't like drawing in those lines of reflections, and it's super hard to nail them. So you've seen it, you've been exposed to it, check mark, we're done. And this 6 through 8, that is just like the example 3 that we did. So give that a shot. See what you can do with those. And 9 through 12, it looks like a lot class, but these are not hard. Basically, you've got those 4 isometries. Which one of those accomplishes the mapping? So just to give you a head start, Q to Q, that one is the translation, okay? All that is a translation. It got slid over. So figure out what took place to get this pre-image to this image, and you're good to go. I hope there's several mistakes in this video, but that should at least help you get done with your homework and not make the same mistakes I did, okay? So, I don't see where I wrote it down. So for 3-4, 1 to 3, axe those 2, and then do 6 through 12. And I really don't think it will take you that long. I'll get the rest of the assignment out later. Y'all have a great day. Bye.